Never gonna give you. Just kidding. Ha, ha, gotcha. Yeah. That was a joke. That was a joke. That was a joke. So these notes are going to be on equations in quadratic form. In quadratic, there's an A in there. Quadratic form. What this means is we're going to be able to solve equations that don't necessarily look like quadratics, or that aren't quadratics, but we'll be able to manipulate them so that they do look like quadratics, and we'll be able to use factoring or the quadratic formula on them to solve them. So there are basic types of these equations. So the basic types is what we're going to start out with. Basic types. This might not make sense right away, but it'll make sense once we go through the examples. So type 1 of these equations will involve square roots. Type 2 will involve an x to the fourth and an x squared, or a variable to the fourth or a variable squared. And type 3 will involve some expression in parentheses. And I'll show you how to deal with each of these types when we get there. So to make it look pretty, type 1, 2, and 3. So these I mentioned, I write basic types because there are going to be some variations, but we can deal with them in the same ways that I'll be showing you in the examples. It's just, it might look a little bit different. So just be aware of that, and let's look at the first example. So we're going to solve this equation. X minus 5 times the square root of x plus 6 equals 0. This is not a quadratic because a quadratic has the highest degree of 2. This one doesn't have a degree of 2. So what can we do? Well, the first trick that we use in these types of equations is substitution. And what I'm going to do is say let the square root of x equal some other variable, and I'm going to call it z. I like to use z just because it's different. So if we say the square root of x, I'm going to call it z from now on. If I square both sides of this equation, what will happen here? It'll give me just x, and I square this and I'll get z squared. Z squared. So just a reminder, square both sides. And this is also a type 1 problem because it's involving a square root. That's what I mean when it involves a square root. It's over one of the variables. So this is type 1. Type 1. Okay? So we've done this substitution. Or no, we haven't done the substitution yet. We've said that square root of x will equal z, and then we found out that x equals z squared. Now I'm going to substitute anywhere I see a square root of x, I'm going to write a z. And anywhere I see a regular x, I'm going to write a z squared. So right here I have x, so I'm going to write a z squared. Minus 5, I don't have any substitution for this 5. I do have one for this square root of x, so I'll write z instead. Plus 6, nothing changes there, equals 0. Now this is a quadratic that I can work with. I can either use a quadratic formula or I can factor it. And right now I think I can factor it because I already did this example. I did this before. It's like cheating. 6 on the top, negative 5 on the bottom, negative 3 and negative 2 will work. Right? 6 and then add them together. Yes. Since we have a leading coefficient of 1, we can use a shortcut. So we'll have z minus 3 times z minus 2 equals 0. Just factored it. And if we set each piece equal to 0, we can solve. Z will equal 3 or 2. But we're not done. In the beginning, we were trying to solve for x. We found z. So we have to still find x. We're not done here. We ain't done. So we ain't done yet. This is a big warning. Don't just stop here. Don't stop. Don't stop believing. Don't stop believing. Hold on to that feeling. We're not done yet. So once you get the z, we still have to figure out what x is. How do we figure out what x is? Well, I've got a formula that tells me what x will be. So I can use this over here. Say actually when z is 3. Wrong color. When z is equal to 3, what does x equal? Well, I could use this formula. X equals z squared. Well, z is 3, so x equals 3 squared, which means x equals 9. So what I'm saying is, when z is 3, I used this equation to get x equal 9. Now I have to figure out what x is when z is my other answer, when z is 2. So when z is 2, I can use the same thing. X equals z squared. So x equals 2 squared, which means x equals 4. So my two answers here are 9 and 4. Now we are done. Alright? We used our z values, plugged it back into these formulas. Let me write this, or highlight this. These formulas, I could have used either one. I chose this one because it gives me x. I could have solved for square root of x, but then I'd have to square both sides and then find x. So I could use these formulas here to solve for my original variable, for x. And I got 9 and 4, so then we're done. So the steps in this problem were, look at the middle term. So we're going over the steps. You look at the middle term to pick your substitution, to choose your z. So look at middle term. Middle term to choose z. So in this middle term, I saw that I had a square root of x, so I said z is going to be the square root of x. Let the square root of x be z. Right? That's how I'm going to choose, and that's actually how I'm going to choose for type 1, 2, and 3. I'm going to look at the middle term first, so it has to be kind of in standard form. So look at the middle term first, choose z, and then move on to the second step. So after you choose your z, maybe square it, or actually you have to square it so that it matches up with the first term. So here we squared both sides to get our first term. This is kind of like a check to know that you're doing it right. If you square your substitution, you should get another one of the terms in the equation. So step 2 is, after you've got both of these things, substitute. So here, instead of writing a square root of x, I wrote a z in my equation. Instead of writing an x, I wrote a z squared to get a quadratic equation. So substitute. Step 3, to solve using the z's. Solve. Step 4, because you're not done, plug back in to find x. So plug back in to find x. Exclamation marks, this is important. Or whatever your original variable was. You can't stop here. I played a song for you, so you won't stop. So Next example. Let's look at the next example. So that was type 1. And this will make more sense as we go along. We'll be doing the same process. So type 2, diabetes. No. That's bad. How do you get type 2 diabetes? I don't know. Maybe I'll look it up later. I can move this up. So this would be a type 2 problem, and we're going to solve x to the 4th minus 9x squared plus 8 equals 0. This one will go a lot faster because we already have the steps. So look at the middle term to choose z. Just like up here, I didn't say z will be negative 5 root x. I'm just taking this, what's under the square root, or what's under my types, actually. That's what I'm looking at. So here, I have an x to the 4th and an x squared. So this is how I know I'm in type 2. And I look at the middle term to make my substitution. So let, instead of negative 9x squared, I just want this piece right here. So let x squared equal z. Then if we square both sides, x squared times x squared is x to the 4th. Z times z is z squared. Same exact idea, we just squared both sides. Now we don't move on to step 2, substitute. So instead of an x to the 4th, I write z squared, and then minus 9, instead of x squared, I write z. And instead of, actually no, plus 8 stays the same because we didn't do anything, also equal to 0. So this is also something that looks like we can solve, either by factoring or by the quadratic formula. I'm going to factor it because it works. So 8 on top, negative 9 on bottom, negative 8, negative 1. Yeah, that'll work. I know it'll work. I know it'll work. I did it before. There's a lead coefficient of 1, so I can go z minus 8 times z minus 1 equals 0. And then setting each piece equals 0, I can get z equals 8 and also z equals 1. So those are the two things that will satisfy this quadratic equation. Okay. So we still have to find x. So when z equals 8, what does x equal? Let's see. Well, I'm going to use this equation now. X squared equals z. So I don't know what x squared is, but I do know what z is. Z is 8. So if I square root both sides, then I'll have x equals plus or minus. Plus or minus, the square root of 8 is 2 root 3. Excuse me. 2 root 3. So this is two answers actually. Then how about when z equals our other value, 1? And I'm going to use this same thing again. X squared equals z, because that's what I said it was in the beginning. I don't know what x squared is, but I do know what z is. So it's 1. Square root both sides. X equals plus or minus square root of 1, which is still just 1. So our solutions here are plus or minus 2 root 3 and plus or minus 1. Gabesh. Nothing too difficult. Again, we're looking at the middle term and making the substitution, not based on the coefficient, but on the variable part.